This PoC protects 6G network services exposed through open APIs. The defense stack covers enforcement, observability, detection, and analytics. Confidentiality, integrity, and availability are ensured via authorization, authentication, and TLS. Security functions are orchestrated by ASPO, PAV, and SSLA. Attack coverage maps to MITR, EFIGHT across 5 threat categories, from initial access and credential abuse to privilege escalation and API abuse. The testbed is a Kubernetes cluster, simulating a 6G API environment. Actors include trusted users or apps accessing the exposed network capability. An attacker role runs each threat scenario. The flow covers initial access, credential abuse, escalation, and API abuse. Real Kubernetes components are combined with scripted attack injection. The solution has 2 stacks. Enforcement uses AP, SIX, Keycloak, OPA, and Vault. Telemetry uses OpenTelemetry, Alumet, Thanos, Loki, Tempo, and Grafana. LOMOS, CANDIL, and trustworthy scoring handle detection and analytics. Together, they form the Secure Exposure Security function. The PoC ties into the MARE security plane via SEPE, ASPO, SFC, PAV, and SSLA. The PoC is measured against key performance indicators. Mean time to detection tracks how fast anomalies are identified. False positive and negative rates track detection accuracy. The API rate limit enforcement rate measures DOS protection at the gateway. Additional KP is track-blocked malformed requests and detection to mitigation time. The enforcement and telemetry stack is fully operational. 3 attack injection scripts are active. API 6 and OPA are deployed and enforcing. Rate limiting triggers 429s under flood conditions. OPA blocks privilege escalation with 403s. Brute force failures appear in Keycloak logs. The demo video shows these scenarios in action. Let me show you first the attack setup, then the attack execution in action. This demo covers the setup and attack scenarios of PoC 10. All traffic flows through APA 6, acting as the policy enforcement point. Every request is authorized by OPA before reaching the protected API. All activity is observed via OpenTelemetry into Loki, Tempo, and Thanos. The stack runs on Kubernetes. API 6 3.11 is the gateway exposed through node port. Keycloak handles identity exposed through node port. OPA is the policy decision point, accessible only inside the cluster. The target app is only reachable through API 6. Grafana surfaces data from Loki, Tempo, and Thanos. Every request hits API 6 first. Rate limiting caps at 10 requests per second, burst 20, excess returns 429. API 6 calls OPA for a decision, a deny returns 403, and allow forwards and triggers telemetry. 4 users cover the privilege spectrum. User 4 and User 6, financial and developer, have network read access. User 5 is support. User 7 is admin. Keycloak issues tokens with the role claim OPA evaluates. The policy defaults to deny. No valid token means HTTP 403. Role must match path and method. Admins have full access. Developers and financial get read only. Support reaches status only. Unknown requests are denied. The target app has 3 access tiers. Status is open to any valid token. Network endpoints need financial or developer role. Admin routes are admin only. Built on fast API with OpenTelemetry, logging every request. Observability runs on OpenTelemetry. Agents forward logs, traces, and metrics to the backends. Streams are labeled by service, namespace, and pod. API 6 emits 403s and 429s. Keycloak surfaces login errors. Scenario 1 is API abuse and denial of service. MITRE T1190. 2 workers run in parallel. The first floods the endpoint above the limit, counting 200s and 429s. The second sends malformed payloads, bad JSON, oversized body, wrong type. Traffic is tagged and logged to a CSV. Detection, a 429 spike, an alert manager alert. Scenario 2 is credential brute force, MITRE T1110 and T1552. Common and random passwords are posted to Keycloak, counting 4 O1s. A second function sends malformed and expired tokens to a P6. Keycloak rejects bad credentials. A P6 rejects invalid tokens. The failure pattern is logged, ready for LOMOS once integrated. Scenario 3 is privilege escalation, MITRE T1098 and T1068. A low privilege token attempts access to admin, user, and config routes. Get, post, and delete are tried on each path. OPA compares the token role against the required minimum. Mismatches return, allowed false, and AP6 returns, HTTP403. The script flags any escalation that was not blocked. Scenarios 4 and 5 are deferred to iteration 2, pending the integration of LOMOS and Candle. Currently, scenarios 1 through 3 are active, covering denial of service, brute force, and privilege escalation. This is the MARE simulation runner, a single Python script launched from the IDE. It automatically handles authentication via Keycloak, confirming our identity layer is ready. The runner executes 4 attack scenarios. First, an API flooding and malformed payload attack hits the API SIX gateway. Second, a credential brute force and token forgery test targets Keycloak. Third, a privilege escalation where a low privilege user probes administrative endpoints. The summary confirms the security chain held. A P6 absorbs flooding and malformed requests, while Keycloak blocked every brute force attempt. Forged tokens were stopped at the gateway, and OPA denied every unauthorized administrative access. These results validate that our enforcement chain, API6, Keycloak, and OPA, is functioning correctly. In iteration 2, the security function will be completed end-to-end. SEPE sends threat alerts to ASPO via LOMOS. ASPO delivers mitigation playbooks to the security function composer. The SFC recomposes the function after PAV and SSLA validation. CANDIL will be enriched with identity and policy telemetry. All MARE components will be fully integrated. Thank you for watching.